When we created our project, Unity made a scene for us automatically. We can see the name of the scene in the top of the window here, as well as in our hierarchy view and within our project under the scenes folder. Now, since we can see our scene name here and have a drop down with all the items in that scene, that does mean we can have multiple scenes open at a time. But that's for another lesson. Let's concentrate on the basics. To create a new scene, you can go to File, New Scene, in which case it's going to create a temporary, not saved, untitled scene, which you can see does not show up in our scenes folder under our project. You can also hit Ctrl N to create a new scene. It is not saved, so you must hit Ctrl S or File, Save As. Now, if you wanted to create a new scene and not have it automatically open, you can right-click, go to Create, and then Scene. Here you can give it a new name, such as My New Scene. As you can see, we're still in the old scene without this one being opened. You can also duplicate an existing scene by selecting it and hitting Ctrl D. This will duplicate it and give a number on the end of it. We can delete unwanted scenes by selecting them and then hitting the delete key. It will ask you if you're sure you want to do this and hit yes. Double-clicking the scene will, of course, open it up. Or you can go to File and Open Scene and select the scene that you'd like. And even if you happen to put a scene in the wrong place, you can always click and drag into any of these folders over here to interactively move it from place to place. With a new scene open, by default, we get a camera and a directional light. We're going to cover those later when we discuss the rendering pipeline, shaders, and how lighting works. Within the scene view, we can click on individual objects using our left mouse button, or we can select them in the hierarchy as well. If we marquee select, we can select multiple objects at once. Notice that when we have multiple objects selected, dissimilar parts of the objects are not displayed in the inspector. Now, to manipulate our camera's view, we can use the middle mouse button and drag the mouse. This will pan our view. To zoom in and out, you can use your middle mouse scroll wheel up and down, or use Alt and the right mouse button to drag in and out and smoothly zoom back and forth. To rotate about whatever you're fixated on with your camera, hold the Alt button and the left mouse click and drag. Now, I mentioned whatever your camera is focused on, that is what it happens to be looking at. This point is important in Unity. To change what you're focusing on, you can select an object and hit the F key, which will move the camera to focus in on that object. If you happen to get lost in your scene and not be able to see anything, you can select the object in your hierarchy, right-click your scene view to maintain focus while still having the camera selected, and press the F key to zoom in. Now, if you happen to select an object with the left mouse button and then click in the scene view, what you'll notice is that object has lost focus. So when you press the F key, it has nothing to focus on. So make sure you select with the left mouse button and you right-click in the scene view and you get this blue bar on the top. Press the F key and you focus or frame in on that object. Alternatively, you can go to Edit and Frame Selected, which you can see is the hotkey F here. Now, at times, you may want to move around in a fly-through mode similar to a first-person game. To do this, hold down the right mouse button and drag your mouse to look in different directions. The WASD keys will then move you based upon where you're looking. W will move you forward, A backwards, and D and A to the right and to the left. Using all these in combination can make it very easy to smoothly move throughout your scene. And if you hold the Shift key, you'll move quicker. You can also use the arrow keys on your keyboard to do the same thing. The scene view also has the scene gizmo in the upper right of the view. This can be used to quickly transition between popular views, such as an isometric view or perspective, and then of course top, front, and the various sides and bottom. Perspective is great when you're trying to get a feel of how your scene may look when it's actually running in the game. Isometric views are wonderful when you need to lay out your scene or figure out the relative sizes of different objects to one another. There is plenty more to cover about the scene view, and as you can see, many icons and drop-downs with many features. But those are the basics for navigation. Let's go ahead and create some game objects. Every object in our scene is listed in the hierarchy over here, and every object in our scene is a game object. Let me say that again. Everything in our scene is a special term called a game object. Game objects are listed in the hierarchy and displayed based on their parent-child relationships. That is, a game object can have child game objects, which can have child game objects. This feature will be important for when we talk about vectors and matrices and how we transform or move objects, especially in relation to one another. But it can also be used as an organizational aid to keep the hierarchy from getting cluttered. For instance, I might place all of my lighting elements inside what we call an empty game object, so I can collapse it down and declutter my view. As an example, I could right-click in my hierarchy and go to Create Empty. This creates an empty game object. I can then select any of these other game objects, click and drag them onto that game object, and you'll notice that they now become child objects to that game object. I can then click on this arrow and those game objects will disappear from the view. And if you right-click and choose Rename or press F2, you can give this game object a different name that's more descriptive. Let's just say it's a group object. We can create game objects by right-clicking in the hierarchy and choosing one of the many different types available in this menu. Or we can go to Game Object and create all of the ones you see here. For now, let's create something simple, a nice 3D box model. Go to Game Object, 3D Object, and select a cube. What you'll notice is that the cube gets created where the camera was looking. It's not at 0, 0, 0. We can check this by going over to our inspector, selecting the cube, and looking under this portion called Transform. Under Transform is the position, which as you can see is -2 dot something, -0.6, 0.19. Wherever our camera happens to look is where the object will be created. Move your camera to some other location, go to Game Object, 3D Object, and this time create a sphere. You'll notice that it becomes created where the camera is now focused. If you right-click and go to Create a 3D Object and a Capsule, you'll also notice that it gets created wherever the camera is focused. Now, when we select one of these different game objects in the hierarchy, you'll notice that a gizmo or widget appears on your screen that changes based upon what you'd like to do. In the upper left-hand corner of our screen is the Grab tool. This allows you to pan the camera around. Next to that are the industry standard Translate, Rotate, and Scale buttons, which can be used with the hotkeys W, E, and R. I say industry standard because it's common for many other applications to also use W, E, and R for Translate, Rotate, and Scale. A notable exception to that is Blender, but if you want to, there are ways of modifying the hotkeys to also use this style. When we switch transformation types, the gizmo is going to change to help us manipulate that object. For instance, if we select one of the objects, say the cube, and we press the Move tool, we'll be given a gizmo with 3 arrows. RGB meaning XYZ. That is, red is the x-axis, G is the y-axis, and Z is the blue axis. The Move tool, or the W hotkey, provides us with an arrow we can click and drag to constrain movement to that axis, as well as a series of planes that allow us to constrain movement in those particular axes as well. Rotate, the next button, or E on the keyboard, provides us with a series of circles around each axis for rotation, as well as a circle around the camera's view, which allows us to rotate the object with respect to how the camera is looking at it. Finally, R, or Scale, allows us to non-uniformly scale along the different axes, or uniformly scale if we select the center gray box. Now, the next 3 icons we're not going to focus on at the moment. Now let's select the Move tool by pressing this Move button or pressing W on our keyboard. And let's take a look at these two buttons over here. There's the global frame, where the axes of your gizmo line up with the world's axes. That is up, forward, and side vectors for the world coordinate system. As you can see here, the blue, green, and red arrow align with the blue, green, and red arrows over here, defining our world space. World space defines how objects are placed within reference to each other. For instance, if you look at the room you're in, your chair is in front of your computer, your monitor is on your desk, and you are sitting on your chair in front of your monitor. We could assign specific XYZ coordinates to every object in your room so long as we agreed on one common center point, say the corner of your room as 0, 0, 0. As you can see within our scene, all of our objects are located within a specific location in the world and have different offsets from that 0, 0, 0 location. However, when you create a 3D model, you don't usually do it with full knowledge of where the object will be in the world. Many times you'll be able to pick up, move, or edit or alter an object. So they make the object in what's called local space, where they position the pivot to a location that is convenient for manipulating the object. If you select one of your objects, hit the E key for rotate, and rotate your object, and then choose local instead of global. Now move to the W key for movement. What you'll notice is that the forward Z vector, blue, no longer is in the same direction as the world space vector. In many cases, it's far easier to manipulate an object from its local coordinate space than it is the world space. Now, just like local and global, there's also pivot or center. Now, with these objects, it's not going to make a lot of sense, and I don't want to spend a lot of time creating an example for you. So I'm going to load up a different scene where objects have specific pivots located at specific spots to show you the difference between a pivot and the center point of an object. Here we are in a scene where there are many different elements of various sizes. For instance, if I select this ladder element here, what you'll notice is that I have pivot selected here and the move tool. And the pivot of this object is down here at the bottom of the ladder. The reason for that is because when placing this ladder, we knew that it would be on the floor and vertical. Therefore, it's easier to manipulate and place with a pivot down there on the bottom. If instead I chose center, what you'll notice now is that it is within the center of the bounding box of the model. A bounding box surrounds the model but is small as possible. This is far more difficult to manipulate if I'm trying to place it properly on the floor. However, if I decided to work with this object sideways or in a different angle, then this pivot point would be more convenient for placement. Now, Unity does allow you to dynamically change, at least temporarily, the pivot point of the object using vertex snapping, using the V key, which we'll talk about more in the future. This allows you to move the object around based upon a selected vertex point and snap it to another vertex, which makes it easy if you know how to properly place vertices. I highly recommend you take a good 10 minutes and manipulate and move objects around your scene, so you have full command of the ability of rotating, scaling, and generally transforming your objects. I recommend practicing until you can do this without looking at the keys of your keyboard or trying to remember what the hotkeys are. Now let's go back to our other scene. Now we have several game objects. Let's move them next to each other. You may have to rotate your perspective view to make sure that they're actually somewhat in line with each other. And go ahead and zoom in on the collection. Go through and start selecting the different game objects, and notice how the inspector updates. Regardless of what kind of object you're selecting, you'll notice that they all have a name, some additional information, and then this component here called transform. In fact, if you select all of the objects together, it will show nothing other than this name and the transform information here. However, you will get this dash in each of these areas. The dash signifies that you have different values across these objects for each of these attributes. All game objects, every single one of them that you create, will always have this information you see here within the inspector. You can, if you'd like to, dial in information by directly clicking on and typing in values. Here you can see I've moved all of the objects to the x-axis at 5 units. I can also click on the label and move them interactively. And if I don't like that, I can move over here and I can even reset the different position, rotation, or scale. You can even copy transform information by going to the settings and going to copy component, selecting a different component, selecting the ... and pasting the component values in there. And now you'll see the cube has the same transform information as the cylinder. But that raises an interesting question. If everything is a game object, then what makes them different from one another? Why does a camera behave like a camera while a light source, well, behaves like a light, changing how things are visible in the scene? How come a model displays 3D data? The answer is that it comes down to what's attached to the game object. And these are called components. As you select the different objects, there are different collections of components that add different features and capabilities to that game object. In the next video, we'll briefly look at components and how you can create your own through scripting in the C# language.